Graphing quadratic equations. This is my third and final example of graphing quadratic equations. The reason that I did a third example for this is just to go over the vertex formula one more time, so you can do it that way rather than by completing the square, as well as something interesting happens with the x-intercepts when we're trying to find those here. So let us go ahead and start with this example. So our function is f of x is equal to negative x squared plus 4x minus 5. And the first two things we need to find is, of course, the most important information. We need to figure out whether our parabola opens up or down, and we need to figure out the vertex on this parabola. So we are not going to put this in vertex form. We are not going to put it in the f of x equals a times x minus h squared plus k form. The purpose of this example is to show you that you do not have to put it in that form. The first thing that we need to figure out is whether it opens up or down. It goes by whether your a value is positive or negative. Well, the a value that you would have in this form is the exact same a value that you would have in this one. So our a value is negative 1. So since it's negative, that tells us that our graph opens downward, which automatically gives us the image of this guy right here, so it looks more like a mountain. To find the vertex of this, two coordinates. The first one comes from negative b over 2a. Negative, my b value is 4 over 2 times, we already said our a value is negative 1. So that's negative 4 over negative 2, which simplifies to be 2. That gives us our first coordinate. Our second coordinate, what we need to do with this 2 is we need to plug it back into our equation. So we need to plug it in for all of these x's. So f of negative b over 2a is f of 2 in this example. So negative times 2 squared plus 4 times 2 minus 5 gives me negative 4 plus 8 minus 5. Negative 4 plus 8 gives me 4, and 4 minus 5 gives me negative 1. So that gives me my second coordinate. Remember, vertex is a point or an ordered pair, so it must be in ordered pair notation. So we know that this parabola opens down, where your vertex is at 2, negative 1. Continuing on, we need to figure out what the y-intercept and what the x-intercepts are. The y-intercept we find by letting our x be 0, so we need to figure out what f of 0 is. All of our x's will disappear, which means we just end up with our constant term. So in this example, our y-intercept is the ordered pair, 0, negative 5. Our x-intercepts, we find that by setting our equation equal to 0. At first glance, it might look like it factors, but it actually does not. So we need to solve this one using our alternate methods. The one that I'm going to use is quadratic formula. So I have x equals negative, my b value of 4, plus or minus square root. 4 squared gives me 16, minus 4 times a times c. Lots of negatives happening there. If I take a 4 times a negative 1 times a negative 5, that gives me a 20 here. So 2 of my negatives cancel out, leaving me with this third one. All over 2 times a, 2 times negative 1, leaves me a negative 2. So it gives me x equals negative 4 plus or minus square root of minus 4 over negative 2, where x equals negative 4 plus or minus 2i over negative 2. Or I could divide both of those pieces by a negative 2 gives me x equals positive 2 plus or minus I. And the reason that it's not a negative I is because I'm going to absorb that negative into the plus or minus. So basically those just flip-flop. But our question becomes, is how do we graph 2 plus I and how do we graph 2 minus I? Well, it's kind of a trick question. I is an imaginary or a pretend or a made-up number. So if it's pretend, then it is impossible to graph. So I could have stopped this example back here. As soon as I figured out that I was going to get an I did not need to continue on farther. If you ever get I in an answer when you're trying to come up with ordered pairs of any kind, not just x-intercepts, but all kinds, that means that they don't exist. So our answer to coming up with the x-intercepts is going to be none. We do not have any x-intercepts because they are imaginary or pretend. So let us put all of this information on a graph and then we'll analyze it with the other things that we need to come up with. So starting with my vertex of 2, negative 1, my y-intercept of negative 5, and I do not have any x-intercepts where this parabola opens down. So it looks like this. Notice that this graph does not cross my x-axis, which double checks that I do not have any x-intercepts. So all of these pieces to the puzzle should fit in with each other. If you're not getting something to match up, you are always more than welcome to graph this using your graphing calculator. Don't be afraid to use that calculator even though I'm not going through all of the steps of showing you how to do so. Alright, now to analyze it. The axis of symmetry is that vertical line that goes through those points there. So vertical lines have the equation of x equals. It's always the x-coordinate of your vertex. So this axis of symmetry is x equals 2. In this graph, we have a high point. We have a top of the graph. So we have a maximum. And that high point of the graph is always your y-coordinate of your vertex. So we have a high point of negative 1. Domain is the x values. This graph goes forever left and forever right. So our domain is negative infinity to positive infinity. Range. We start at the lowest part of the graph, which this one is negative infinity because it goes down forever, up to the highest part of this graph, which we found in part H, which is negative 1. Negative 1 is part of the graph, so we will use a bracket on that. So we have found all the important points on this graph, and we have analyzed it with the other things beyond. So we have done 3 examples of all of the steps of graphing and analyzing quadratic functions.